Today we're going to concentrate on arithmetic series. So for the warm-up, consider the sequence 1, 2, 3, 4, 5. Is it arithmetic or geometric? What's the common difference or ratio? Can you write an explicit formula to represent the sequence? Okay, so this one you should know is arithmetic. There's a common difference here. It is plus 1. The explicit formula, we need a slope and a y-intercept. We know the slope is 1. The y-intercept would be the 0 term in the list, so I have to go backwards 1, so it would be 0. So you could write y equals 0 plus 1x. You could write y equals x. It is linear. Use sigma notation to write the sum of the first 8 terms and find the sum. All right, so here's the sigma. We want to go from the first term to the 8th term. And we need to put the explicit formula here. Instead of x, I'm just going to write n. And then find the sum. So then you just add them up. 1 plus 2 plus 3 plus 4 plus 5 plus 7 plus 8. You would add them up. I'll let you guys do that. All right, that's not so hard to do, but what about this? Find the sum of the first 100 terms. Here's sigma notation for that. But can you find those terms without actually adding them all up, just like we did in the first one? So in class, we watched this video about how Carl Friedrich Gauss found a shortcut for adding up the first 100 numbers, 1 to 100. And so we're going to take a look at that video in class. You can YouTube and watch it too. I won't put it in this video. All right, so a sequence versus a series to review. A sequence is your list of numbers. The series is when you add them up, when you sum the sequence. Okay, so here is Gauss's method for finding the sum of the first term, 100 terms. So again, he thought about adding up all the numbers all the way to 100, but then reversing it. And he found that each of these sums right here was 101. So what he did is he thought about multiplying 101 100 times, but then dividing by 2 because he looked at 2 of the sequences instead of 1. And then he got the answer, which I believe is 5,050. We better double check that. It's been a while since I've done this. All right. All right, so 100. Yep, 5,050. All right, so there it is. A formula for Gauss's method. Here it is. To find the sum of any number of terms, like the first 100 or so on. You take your first term, like 1. You take your last term, like 100. Multiply by how many terms there are. So here it's like adding them up. First term plus last term was 101. And then we multiplied by how many there were 100 terms, so that's times n, divide by 2. Okay, so there's what that formula looks like. First term plus last term times number of terms, divide by 2. That is essentially what Gauss did right there. Okay, so let's practice doing that. Evaluate the following. Okay, so we could list out all the terms. So we could, and I'll list out some, not all of them. 2 times 1 plus 3 plus 2 times 2 plus 3 plus, and so on, all the way to 15. But that's kind of long. So let's use Gauss's formula. It's a little bit faster. I'll write it up here. So he would say find the sum of the first 15 terms. To do that, you need the first term plus the last term times the number of terms divided by 2. Okay, so you just need 3 things. First term, last term, number of terms divided by 2. And again, this should be an A. It looks like an N, but there's your A. Okay. All right, so we need the first term. The first term, I'm going to do my work over here. First term, 2 times 1 plus 3, which is 5. We need the 15th term, 2 times 15, which is 30, plus 3. That is 33. All right, so now we can plug into Gauss's formula. We have everything we need. The sum of the first 15 terms is 5 plus 33 times 15. There's 15 terms we want the sum of. Divide by 2. Enter that in your calculator. Make sure you hit enter before you divide by 2. So we have 5 plus 33. I hit enter there. And then times 15. Divide by 2. So the sum of the first 15 terms is 285. Okay. Let's try the next one again. I wouldn't want to list the terms. Oh, sorry, I didn't show my answer here. Okay, So here's what I put for my answer. So you plugged it in, we get 285. Again, to list out the terms, you'd have to start at the fifth term. 3 times 5 minus 5 plus 3 times 6 minus 5 all the way to 3 times 17 minus 5. That's a pain. Let's not do that. So instead we'll use Gauss's formula. All right, so the sum of the 5th to the 17th term. Ooh. Okay, so to do that, we're going to find the sum of the first term. Oops. We're going to find the first term, which is here, the 5th term, plus the 17th term, times the number of terms divided by 2. And I want to show you a shortcut for finding the number of terms. Okay, so to do that, let me give you an example of that. Okay, so quick tangent here. To find the number of terms, I'm going to open a new page. So let's say I had this list. 1, 2, 3, 4, 5, 6. Okay, there's my sequence. And let's say I wanted the sum of the second term to the 5th term. My question is, how many terms is it from the 2nd to the 5th? We can count. It's 1, 2, 3, 4. That is 4 terms. Now, the shortcut to finding that with the numbers 2 and 5 is we can take 5 minus 2, but then add 1 to that. Okay, so again, if you want to know how many numbers there are without actually listing them out and counting, you take your top term number minus your bottom term and then add 1. So another example is, let's say I wanted the 5th term to the 12th term. How many terms is that? You could take 12 minus 5, but then you have to add 1 back into that. Okay, so again, if you wanted to see, so 12 minus 5 is 7, so that is 8 terms. How do we know that? Again, if I look at my numbers here, I'll just list the numbers. I'll use a different color. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I went from the 5th term to the 12th term. 1, 2, 3, 4, 5, 6, 7, 8. You can see that's 8 terms. So again, you do subtract them, but you have to add 1 number back in. An easier example is like from the 1st to the 2nd term, 2 minus 1 is 1, but then you have to add 1 back in because you know from 1 to 2, that is 2 numbers here. All right, so that's the shortcut. So let's go back then to our notes. And so here, how many terms is it? 17 minus 5, but then add 1. 17 minus 5 is 12 plus 1. That is 13 terms right there. So here, n is 13. That's the first thing I need, number of terms. We also need the 5th term and the 17th term. All right, so let's do that. The 5th term is 3 times 5 minus 5. 3 times 5 is 15, minus 5 is 10. Okay, so there's the 5th term. Let's do the 17th term we want here. All right, so the 17th term is 3 times 17 minus 5. All right, so that is 46. All right, so now we put it all together in the equation. So I'm just going to say S for the sum is 10 plus 46 times the number of terms which we determined was 13, divide by 2. I'll set my calculator. 10 plus 46 and enter times 13, divide by 2. Ooh, I get a decimal. Okay, so let's redo it again. 10 plus 46, enter, times 13 divided by 2. Okay. So our answer, I divided wrong, is 364. So that sum is 364. I better double check that. Okay, so 56 is 3 divided by 2. Okay. What? Okay. 10 plus 46. I'm getting the wrong thing. 56 times 13 divided by 2. Yep. Okay, so 364 is the sum. All right, so let's do it one more time. Again, this is for anything that's arithmetic. First term plus last term times number of terms divided by 2. And so we know that here from 1 to 32, that's 32 terms. Again, if you didn't know that, 32 minus 1 plus 1. 32 terms is n. All right, so we need first term. We need our 32nd term. And we know the number of terms is 32, and we can plug in. So here's the first term, 2 times 1 minus 10. 2 minus 10 is negative 8. Last term, 2 times 32, which is 64, minus 10, which is 54. Okay, so let's plug into our sum formula. The sum formula is first term. Oh, that looks terrible. Okay, so first term, -8, plus last term, 54. Again, looks terrible. Times the number of terms divided by 2. So type that in our calculator. -8 plus 54 times 32 divided by 2. The sum of all these numbers in the list, if we were to list them out, would be 736. So the sum of the first 32 terms, 736. Now, Gauss's formula only works if the sequence is arithmetic. That is very important to note because not all sequences are arithmetic. So only if it's arithmetic. So for example, this is not arithmetic, this is quadratic. So if I ask you to evaluate this one, we have to write out all the terms. So here, it'd be 1 squared minus 1, it's only 3 terms, plus 2 squared minus 1, plus 3 squared minus 1. So you just list out the terms. All right, 1 minus 1 is 0. 4 minus 1 is 3. 9 minus 1 is 8, and so this would be 11 for your sum right here. So the sum of the first 3 terms would be 11. Okay. There's one more here that we'll go over and then we'll have time to practice. Okay, so the school auditorium has 59 seats in row 1, 63 in row 2, 67 in row 3, and so on. Can you write the recursive formula? Okay, so the recursive formula, I'm going to make a table. So here's the row, here's the seats. Okay, so row 1, 59. Row 2, 63. Row 3, 67, and so on. You can see this is arithmetic. It looks like we're adding 4 every time. The recursive formula is first term 59. To find, oh, I should use A. To find any term, we take the term before it and we add 4. So there's the recursive formula. The explicit formula, we need slope. We have that. It's 4. The y-intercept, we go backwards 4. So 59 minus 4 is 55. How many seats are there in row 11? Let's use the explicit. That's easier. So that would be 99 seats in row 11. How many seats are there in the whole auditorium? There are 25. All right, here's the sigma notation. So start with row 1, go to row 25. Here's our rule. But we want the sum. Okay, so for the sum, we need the first row. First row, we know there's 59. We need the 25th row. So that is 4 times 25, which is 100 plus 55. So that's 155 seats in the last row. All right, let's plug into the formula. Sum of the first 25 rows. First row plus last row times number of rows divided by 2. So I can let you calculate that. How many seats are there in row 5 to 10? So we need the 5th row, we need the 10th row, we need number of rows, which is 10 minus 5 plus 1. 10 minus 5 plus 1 is 6. 5, 6, 7, 8, 9, 10. Yep, so that's 6 rows. All right, let's find a sub 5. It would be 4 times 5 plus 55. That's 20 plus 55 is 75. 4 times 10 plus 55 is 95. All right, so we have everything we need here. Let's plug in to find the sum. And that would be the 5th row plus the 10th row times the number of rows divided by 2. Calculate that. We'll give you the sum of row 5 to row 10.